Welcome to Programming Minds. In previous video, we have learned how to implement binary tree using C++ programming language. In this video, we are going to learn binary search tree using C++ programming language. So let's get started. Now let's understand what is binary search tree first. Binary search tree is the same like binary tree with following properties. The left subtree of a node contains only nodes with a key lesser than node's key. This is the first property of binary search tree. The right subtree of a node contains only nodes with a key greater than node's key. This is the second property. And third property is there must be no duplicate nodes in the BST. Okay, so here we have taken one example of binary search tree. So first element or the root element of that tree is 12, and as properties of binary search tree, left subtree of a node contains only nodes with a key lesser than node's key. Okay, so left side subtree should be smaller than 12. So as we can see, whole left side subtree is smaller than 12. We have biggest element as a 11. And as second property says, all the right side element are the greater than 12. Okay, there must be no duplicate nodes in the binary search tree. So as in this binary search tree, we cannot see any duplicate element in the binary search tree. Okay, so if we check smaller trees, smaller subtrees, let's assume we have this smaller subtree. In that case also, left side child is smaller than 6 and right side child is greater than 6, which is 8. And every subtree follows the rule of binary search tree. So this is how binary search tree works. Now let's go to the Visual Studio and let's implement binary search tree using C++ programming language. Let's get started by including libraries. Hash include iostream using Insertion standard. Let's write main function 0. For the implementation of binary search tree, we are going to use object-oriented programming. So let's write one class node in public section. So the node of a binary tree contains data member, left side pointer and right side pointer. So let's create integer data member and node pointer, which will be pointing to the left side nodes, another node pointer which will be pointing to the right side node. Now let's create constructor of node class. Here value of data will be 0. Left will store null address because there will be no left or right side child present when we are creating object of a node class. Let's create another parameterized constructor. Let's pass integer value to it, and in that case data will be value and left pointer will be null as well as right pointer will be null. Okay, so this is how we are going to build the node. Now let's create another class binary search tree. Let's take it as a BST, and in public section we are going to define node root. Okay, now let's create constructor of bst, and root will be null in first case. Now let's implement one function which will be return true or false, and it will be help us to check if tree is empty or not. So boolean is tree empty, and into that function we are going to check if root is equal to null, and it will return true, else it will going to return false. So by this method we can check if binary search tree is empty or not. Now let's implement function to insert node in the binary search tree. So let's define one function void insert node, and into that function we will be passing new node. Okay, so node, new node, we will be getting new node into that function, and we are going to arrange it in binary search trees proper as per binary search trees properties. Okay, so in this function we will first check if root is equal to null, then we will assign new node to the root. Okay, so root will be new node, and we are going to print message value inserted as a root node. Okay, so this statement will gonna call when there will be no element in the binary tree. Okay, now for else if there are already root element is present, then we are going to call else, and here we will create one temporary node to traverse through whole binary search tree. Okay, temp will be root. So we are going to start traversing from root, and let's define one while loop where we check if temp not equal to null. If temp is not equal to null, this while loop will keep running, and in that case we will check if new node dash data is equal to temp or data. In that case, if as binary search trees property says there should be no same data or same values present in the binary search tree, so in that case we are going to print message already exist. Okay, and we will just return in that case. Okay, this is the first case. In second case we are going to check else if new node data is less than temp data, and temp left equal to null. So in that statement, we are going to check if new node, which is we are taking here new node to insert in the binary search tree, if new node data is less than temp node data. That means if new node is less than root, then we are again check if temporary left is equal to null. In that case, we will assign that data to the as a left side child. Okay. So in that case, we are going to do like this. Temp left will be new node, and we will print a message element added at left of txt, and we will take the while loop. Okay, this is the second case. Now let's go to the third case. Else if, so in that case we are going to check new node data is greater than, we have done for left node. Now let's new node data is less than temp data, and we have executed this case above. Now for third case, we are going to check else if new node data is less than temp data, and temp left is not null. In that case, we are going to just traverse to the left of temp. Okay, so temp will become temp left. We just go to the subtree here. Okay, and in next else if, we will check new node data is greater than temp node data, and temp node right is equal to null. In that case, we will assign new node to the right side of a temp. Okay, so new node, and we are going to print message as element added at the right of est. We are going to break this statement here, and in the last statement we are going to check else. We are going to traverse to next of the right. Okay, so it will be become temp right. Okay, this is the method to add new element in the binary search tree. Okay, in the C++ programming language. Now let's create one function to print the element from the binary search tree. So let's use void print reorder. We have learned the implementation of pre-order, in order, and the post order in last video. So I will just give you brief about code only. So let's check how the print pre-order works. Okay, so in that case we need to pass just node. So node, there will be node. Okay, and we will check if node is equal to null, then we are going to return. Okay, and we will start printing data here of binary search tree. Cout node data, we will give some space here. Okay, and we will call this function recursively for left side elements and the right side elements as well. Okay, so we will just pass left here and node right here. We have implemented function to insert node in the binary search tree. Then we have implemented function to print pre-order elements of the binary search tree. Now let's go to the main function and define one object of binary search tree. So bst b1, and let's define one object of a new node. So we can define it as a node, and new node, new. Okay. So and so, in that case, we will define node data as a 10. Then we can pass that new node into B1. So insert node, and we will pass new node. Okay, let's create node 1. Node 1 data will be 20. We will pass node 1 here. Then let's create node 3. Let's pass 8 to it, and it will be node 2. Node 2, just copy it, pass the node 2. So this is how we are going to insert the new nodes into B1 binary search tree, and we will just print the by using print pre-order. Okay, let's pass new node to it. Okay, let's run the program and check if it's working well. Click on local Windows debugger. Program is running successfully and there are no compilation errors. So we are adding new elements in the binary search tree. So we have added 10 first, and we see the message as a value inserted as a root node because there were no elements in the binary search tree. Then we have added 20. So element added at the right of BST. Okay, so because 20 is greater than 10 and the binary search tree's rule says uh, greater elements will be added at the right side and smaller elements will be added at the left side. So it is added at the left side of BST. So this is the successful implementation of binary search tree using C++ programming language. If you like this video, subscribe to the Programming Minds YouTube channel, share it with your friends. Thank you.